Wingsuit flying, probably the most extreme form of non-powered human flight, where adrenaline junkies throw themselves out of planes and off of cliffs wearing flying squirrel style suits. Now, I'm not currently willing to give this a go with the limited or no experience I have with any kind of skydiving or base jumping, so I'll be following a suggestion left by the following user to build a remote control wingsuit skydiver or base jumper. Now, I've been doing some research online about how these wingsuits are controlled in the air, and apart from the odd forum post or YouTube video about how to control a wingsuit in Just Cause 3, I couldn't really find any legitimate information about how the real wingsuits are controlled. But either way, let's get on with the build and I'll show you my rough idea of how I think I can control this. So I've finished 3D printing the 4 main sections of the remote control wingsuit. I've got to say a quick shout out to my 3D printer sponsor. They sent me some new filaments of PLA and it's turned out really nice, so thanks to 3D Prints UK for that. You may be wondering why the web sections of the wingsuit are 3D printed as solid, and there are a number of reasons for this. One of the reasons is I'm not very good at sewing, but that's not the main reason. The main reason is that for full-size wingsuits, there's actually 2 layers of material, and the airflow coming in from the front gets caught by small pockets which inflate the 2 sections like a bouncy castle, and these inflate to produce sort of an aerofoil shape. Now that's quite hard to replicate at this small scale, especially with my bad skills of sewing. So I thought, why don't I just 3D print it as solid? This guy's legs don't need to move in and out or whatever, so it doesn't really matter, you know, it being solid. So anyway, I'm going to get on with installing the electronics into the body, and then I'll show you my thoughts behind how I'm going to control this. So here you can see the main body of the wingsuit. As you can see, it's quite a complex design. I spent quite a few hours trying to make everything fit inside this compartment, because basically all the electronics for the wingsuit have to fit inside this section. And to give you an idea of what kind of electronics I have to fit in here, let's start with the small servo, which sits up front. This servo hopefully controls the deployment of the parachute. And then there's a larger servo on the side here, which controls the left arm. Then there's another large servo on the right here, which controls the right arm. And then in this small compartment at the back here, I have to fit the battery to power it all, and also the receivers to control it all. Now, as you can see, it's a pretty tight fit between all these electronics, and even after spending so many hours of designing it, I still think I'm going to have to trim off the tabs of these servos and also shorten the wires and probably decase the receiver as well. But either way, let's get on with the build. So I've cut the tabs off the side of this servo, however the way that I'm going to mount them, roughly like that, the wire sticks out the sides of the body, so I'm going to have to modify that somehow. So the 2 large servos fit in quite nicely, they're looking quite neat. The front servo, the slightly smaller servo, I only had to take one of the tabs off, because the front tab will be used to bolt the servo into position. I think what I'm going to do is trim the wire of this servo and then solder up the receiver. So what I'm doing now is directly soldering the servo wires to the receiver, and this is to save space, makes the receiver a lot smaller. To give you an idea, this is the size of the receiver beforehand. So there's quite a big difference in size. Plus, if you had the servo plugs plugged in, it's quite long in length, and this wouldn't fit inside the body. So I'm just directly soldering them to save a lot of space and also some weight. So now you can see that the receiver is soldered up with all the servos, and it fits quite nicely in there. A lot more room than if I use the original case, which barely fits in either way. So now it's time to solder up the voltage regulator and the battery to power the servos. So this battery pack will power all of the electronics on the wingsuit. It's rated for 7.4 volts, roughly minimum, and about 8.4 volts when it's fully charged. However, all the electronics prefer to run on about 5 volts of power. So I'm using this very small voltage regulator, which is variable, you can adjust it. to regulate it down to 5 volts. However, I'm not sure what the factory voltage is set on it. So I'm just going to plug this in and grab my voltmeter to check the voltage output on it. So it's outputting about 7.3 volts, so it doesn't seem to be doing very much. So let's just adjust the dial on here. So it's now regulating the voltage to 5.2 volts, which is close enough and should work fine. So I'm going to solder it into the receiver and we'll check if all the servos are working. So I've now soldered the 5 volt regulator into the 5 volt points on the receiver, and we're going to turn on the radio. And then plug in the battery and see if we can get some movement on these servos. So, if I move this, seems to be working. So it's time to heat shrink the regulator so that we don't have any shorts inside the body, and see if we can squeeze everything in and mount these servos properly. So all the electronics are now mounted into the body pretty solidly. The front servo is a bit loose, I need to put a bolt through there to hold it secure. As you can see, the servos move, and then the idea is that the arms will mount on the side like this, using 2 bolts. So now all the electronics are mounted, the servos are attached to the wings and the wings are on their pivots, and as you can see, I can now flap the things around and it looks like a bit of a crazy bat or weird bird. Now I've just got to fit the rear legs on, put a couple bolts in there, and also I need to print the head and the parachute deployment hatch. So it's looking pretty good right now. I'm glad all the electronics fit. Let's get on with the rest of the build. So I've finished 3D printing the final pieces of the remote control wingsuit. Here I have the head, which I know looks a bit ridiculous. I just drew it up in CAD pretty quickly. This hatch will cover up the electronics, protect them from falling out, and also stop the parachute from getting caught on any sharp pieces or cable ties. And then this will hold the parachute in position before it's deployed. So let's quickly get these mounted. So there we have it, the finished remote control wingsuit. Apart from the parachute, obviously, I'm waiting for some ripstop nylon in the post. Some of you might be wondering, why does this side of the 3D print look so awful? And I printed everything this side up, so the support material didn't really come off that well, and I tried to sand it smooth. Unfortunately, it made everything go a bit white, but either way, it does its purpose. And let me just show you roughly how it's going to work. So, from what I mentioned at the start of the video, I couldn't find much information about how these are actually controlled when you fly down a mountain or out of a plane or whatever. The only thing I could find out was that they decrease and increase dihedral in their arms for pitch control. So the centre of mass of a human is roughly just above the hips, like about here. So increasing or decreasing dihedral increases or decreases the amount of lift at the front. So if you increase the lift here and the centre of mass is here, that creates a pivot point which will hopefully pitch it up, and then the opposite, if you go like that, it should pitch it downwards. I'm not sure how well this is going to work, but I can't really do anything else right now. For roll control, I couldn't find any information, so I'm hoping that just moving the arms individually will cause some kind of turning movement. I guess we'll have to find out once I drop it from something. For parachute deployment, I have it rigged up to a switch at the back of my transmitter, which if you watch this servo, it just unhooks this hatch. So right now it's locked down, and then if I click the switch, it unhooks the hatch. Just a really simple mechanism, and the parachute will be sandwiched in between these 2 plates here. Once that's open, I can also open this hatch, which has all the electronics underneath, This hatch is, well, as I explained, is just to protect the parachute from getting caught on anything sharp, and also stop the electronics from falling out. I'm going to Velcro or stick it down in position anyway, so that if this hatch does happen to come open, it won't cause any issues. Now, I'm sure some of you are wondering about the weight of this thing and how the weight scales to a real human being. This guy is about 1 foot tall. I'm about 6 foot tall. And if I was this tall, I would weigh about 370 grams. So let's stick him on my scales. And he weighs in at about 299.9 grams. So let's say 300 grams. So he's slightly lighter than what I would be if I was that size. If I do some quick maths, he would weigh about 65 kilograms if he was 6 foot tall. Which is a bit on the light side, but I suppose it's a good thing. Hopefully that means he'll glide a bit better. Another interesting thing, which I've actually already mentioned when I was talking about the control of the mannequin, is that the centre of mass of a human is about here, just above the hips. So let's just check if this guy will pivot about there. Yeah, so he seems to pivot about the stomach area, which is not far off a real human being. So yeah, you might think I did some pretty cool calculations to work that stuff out, but if I'm honest, that was total luck. So the centre of mass seems to be pretty good, and also the weight of the guy seems pretty good. So that wraps up part 1 of the remote control wingsuit model. I'd like to thank you very much for watching. Subscribe if you want to see more. Next week I'll probably be building the parachute for this model, and also I need to build a drone to drop it from. I don't currently have an aircraft that will be able to lift this to a high altitude and drop it, so that'll be quite interesting. Huge thanks to all my patrons for supporting me. If you wish to support my videos, then check out this box up here. They make these weekly videos possible, so huge thanks to you guys. Anyway, thanks once again for watching, and I'll see you next week. Goodbye.